Okay, volume of revolution here, and this is a nice problem. What we have got is we have got a curve y equals x squared plus 3, and we're going to try and find take this shaded area, we're going to spin it around the x-axis, and when we do we'll create this sort of bowl shape and we want to know the volume, and we're going to do this by integration. Before we start, worth pointing out that with integration we commonly do two things. We find areas and volumes. Volumes is the one we want to find in this case. Both of them are integration. Both of them in this case would go between those vertical lines x equals 1 and x equals 3. If we wanted an area, we would be taking all the y values and we would be travelling along and adding up all the y values for that function. So we integrate y values dx, and in this case the area would be integral between 1 and 3 of x squared plus 3 dx. And if we want a volume, what we do is we take those y values, but instead of adding those up, what we do is we spin them around the axes and we take all these disks, and as we go along what we do is we spin all those y values, create all those disks, add them all up by integration, and we get ourselves a volume, a neat trick. And the area of these disks that we want to add up, well, area of a circle pi r squared, so pi y squared, all the disks, pi r squared, pi y squared, all the way between 1 and 3, integrate, add them up, and that will give us our volume. And in this case what we want, well, we've got 1, we've got 3 pi. We know what our y is, it's x squared plus 3. So pi y, we've got to square that and integrate. We're not too interested in the area, we're not being asked that in this particular case, so I'll get rid of that one and I will bring this volume question to the front here. So if we ever want to create a volume, then that's our formula. Integrate pi, whatever y is squared, between the values we want, and we get our volume, our spinning volume. Let's go ahead and do this. So we have a bit of a problem with the squared. We don't want to deal with this bracket as it is, so what we will do is we will remember to get rid of this bracket before we integrate and multiply this out. X to the power 4, 6x squared plus 9. That's what we want to integrate. Let's go back here. So pi that's what we're integrating. The pi can be inside or outside the integration. It's just a multiplier. It sits there doing not too much. I'm going to leave it inside for the moment, and let's do our integration. So up the powers and divide, up the powers cubed and divide. 6 divided 3 gives us 2, and 9 becomes 9x, and that between 1 and 3. Leave my pi there. So I will put 3 into this formula, get an answer. I will put 1 into the formula, get an answer, and I will subtract the 2. So 3 to the power 5 divided 5, 2 times 3 cubed, plus 9 times 3, and pi times 1/5 plus 2 plus 9. And work all this out, throw it in your calculator, do whatever you need. What we get is pi multiplied by, I think, 118.4. You'll guess that I didn't do that in my head just then. I've done that before I set off, and that is my volume. There we go, a volume of revolution, always the integral of pi y squared dx if I spin it around the x-axis. And in fact I'll put that around x-axis. Always works. Off we go, do the integration, and we have ourselves a volume. Neat trick. And what I'll do is I'm just going to check this. I'm going to check this by using Wolfram Alpha. So I'll go online and I will simply ask it to, if I can spell this I will do, integrate pi times x squared plus 3 squared between 1 and 3, and let's have a look, see what it tells me. I'm rather hoping for the same answer. 592 pi over 5, and that will give me, I believe, 118.4 pi or 371.96. So there we go, Wolfram Alpha agrees. We, I think, are on the right track, and that is our volume of revolution.